Okay, if you have not watched the percent error video and completed the first two practice problems, if you could go on and stop this video, watch the first video, complete the last three practice problems, and then come back to this video. If you have completed that, I need for you to unsubmit your slides so you have access to your slides so you can check to see if your answers are correct to what I'm working out in the video. You may have to kind of pause and start it again. Okay, so we're going to start with our practice problem or the independent practice for the percent air 3 problem. We have the boiling point of water is known to be 100 degrees Celsius. The experimental results recorded for the boiling point of water was 97.5 degrees Celsius. What is the percent air? Okay, so a method that you can use that may be helpful with solving your problems today in class is to read your problem, and we're going to assign colors. So we're going to say the measured value, we're going to make that red. And we're going to say blue is going to be the accepted value. So when I go to look at my numbers, the boiling point of water is known to be. So I know that known is another word for accepted. So let's underline that in blue. And then the experimental results. We know that the results may not be accurate. So 97.5, that's going to be our measured value. So this is just a way that sometimes read the problem, pull out the numbers that are important, and then underline them, identify which one's measured, which one's accepted. And then from there, you can go on and plug into your formula. So remember, your formula is measured minus accepted divided by accepted times 100. So we have 97.5 minus 100 divided by the accepted value again, which is 100 times 100. So when you're entering this in the calculator, please make sure that you enter it as 97.5 minus 100, enter, divided by 100, enter, times 100, enter. So that way it goes and the calculations are made correctly in your calculator. So when you end up after plugging it in, you should have a negative 2.5%. And remember, it is okay to have a negative percent error. Okay, so with practice problem number 4, we have a student calculated the specific heat of aluminum to be 0.56 calories over grams times degrees Celsius. The reference section of your chemistry textbook stated the specific heat of aluminum to be 0.185 calories over grams times degrees Celsius. What is the percent error? First off, if this information right here, calories / grams times degrees Celsius, if that is confusing you, scratch it out. Okay, this is the specific heat label or unit, like meters is M, centimeters is cm, grams is G. We'll be working with specific heat. We'll talk more about the definition and why it has all of those units in the one in unit 2. Okay, so if that's confusing you, scratch that out and just focus on your numbers, because remember, your percent sign is what we need with our answer. So we have a student that calculates. So is a student going to be accurate? Possibly, but they may not be. So we're going to go on and underline that in red, because we said red was going to signify our measured value. And our textbook, if we're referring to the reference section, the back section of our textbook, you'll see in our e-text that they have different tables in the appendix. We know that that's accurate. That's the accepted value. So we'll go on and underline that in blue, and we're ready to solve. So our measured value is 0.156 minus the accepted value, which is 0.185, divided by the accepted times 100. And again, when you go to enter this in your calculator, you'll have 0.156 minus 0.158, enter, divided by 0.185, enter, times 100, enter. And for your answer, you're going to get a negative 15.6%. And our final practice problem, we have an experimental measurement was taken of 10.4 milliliters. The actual measurement was 9.7 milliliters. What is the percent error? So let's identify first our measured value, and we're going to underline that in red. So 10.4 is going to be the measured value because it says experimental, okay? The actual or the accepted is going to be the 9.7. And now we're ready to plug in and solve. So we have our measured, which is 10.4, minus the accepted, which is 9.7, divided by 9.7 times 100. So break it into your calculator into parts. So 10.4 minus 9.7, enter, divided by 9.7, enter, times 100. And your answer will be 7.23%.